Oh, there you are. So here we go. The mean value theorem for integrals and the average value of a function. This briefly. That work in the background or the foreground or whatever ground we want it to be in. It'll pop up at some point as we're moving through, and I'll quickly dismiss it. So the mean value theorem for integrals. It looks just like this. Okay. So the f of c minus b times b minus a is equal to the integral from a to b of the f of x dx. Okay. So essentially what this is talking about, f of x, the integral from a to b of the f of x dx, think of that as like kind of remember the area under the curve. Okay, as we wait for the TI smartphone thing, I could have done this before, but I was not paying attention. So, so that may be going on in the background. So anyway, so this part is the area. This is the width. Oh my God, it's crazy. All right, so this part is the width. This we'll think of as the area. And f of c is some sort of a height. Okay? So what the mean value theorem for integrals says, some place between a and b, there's a place c, so that the height times the width gives me the area. Okay? I think of this as the Goldilocks and the three bears theorem, and I'm going to show you now why I think that way. Okay? So if I were to draw a rectangle using the left endpoint, like so, that would give me too little area, right? If I were to use a rectangle that was on the right endpoint, that would give me too much area, okay? But somewhere along, somewhere between A and B, there's a place where I can draw a rectangle. Oops, just try it. I thought they were going to come with this, but it would have been so much nicer. Okay, so it's just right. You can see that I got a little overage here and a little underage there. And so between this overage and that underage, I'm just right. Okay. So from the left end point, I'm too small. For the right end point, I'm too big. But somewhere in between too small and too big, we've got to have just right. All right. Does that make sense? That goes back to the blob theorem as from the way back. So we tend to refer this as the I don't know. We might be a strong word. Ooh, that could disappear. I tend to refer to this as the Goldilocks and the three bears theorem, mean value theorem for integrals. Okay. So we're looking for the just right rectangle. That's what we're getting at is with the mean value theorem for integrals. Here's the area, and we've just got to figure out where that value is that gives me the just right rectangle. Whoa. So use the mean value theorem for integrals to find the value of c for this thing. So we're just going to set this thing up. Okay, we're just going to run through it. There's my pen. All right, so the f of c, that means plug c into the function, c to the fourth, times b minus a, 3 minus 1, equals the integral from a to b, 1 to 3, of x to the fourth dx. So we can do this part. We can do the left part really easily. So x to the fourth becomes x to the fifth over 5. We integrated at 3 and 1, so we've got 3 to the fifth over 5 minus 1 to the fifth over 5. 3 to the fifth is, let's see, 3, 9, 27, 81, 243. So I've got 243 fifths minus 1 fifth. I think that's 242 fifths. Okay, so that's taking care of the right side of the equation. That's the integral side. That's the area under the curve. Under the curve, we have 242 fifths. On the right side, we've got 3 minus 1 is 2, so I've got 2c to the fourth equals 242 over 5. I'm going to extend a little bit further. So that means that c to the fourth is equal to 121 fifths. And so c is going to be equal to the fourth root of 121 fifths. Well, here's why we have the calculator out, I guess, huh? Let's get out of there, get out of there. Clear that. So I've forgotten totally what the numbers were. So I need 121 fifths, and then I need the fourth root of that. So 121 fifths. So let's try this. Parentheses 121 divided by 5. Parentheses raised to the 1/4 power. Seems to do it, right? That's the fourth root, 1/4 power. I'm going to end up with 2.21 7, so c equals 2.217, which is somewhere between 1 and 3, so that's a good thing that it works. It kind of gives us the feeling that we've got the possibilities. I suppose we should continue to consider the positive and negative, but we don't, because you don't worry about the negative. It's not in the root, not in the root. It's not in the interval. That's the word I'm looking for. So there it is. That's where that would be the c value that we would draw the just right rectangle. So if we had this curve x to the 4th, which maybe looks like that, it goes through the origin, but general idea, between 1 and 3, right about here, I would draw the just right rectangle. Okay? That's how it works. Mean value theorem for integrals. Then there's this other thing called the average value. Okay? So the average value is the integral, the area, and divided by the width. Right? 1 over b minus a. b minus a is the width of my interval. So 1 over that is like dividing by. So basically, what I've got is I've got the area divided by the width. And that basically, the area divided by the width gives me the height, right? Okay, so the average value is just the area divided by the width. So what I tend to refer to that, I'll tell you, if you're doing an average value, you do the integral, and you divide it by the interval. Okay, the integral, that's this part, divided by the interval, so that's the width of that's the width. Integral over interval, average value. Say it with me. Integral over interval, average value. Okay, so here's the thing I'm going to show you that you're probably really going to like. Okay, it's called the setup. So if I want to find the average value, I do what we call the setup. And the setup is we write the equation down. 1 over 2 minus negative 1 times the integral from negative 1 to 2 of 4x cubed minus 3x squared dx. Okay, that's called the setup. We've written down what we want to be able to do, and now here's the beauty. We go to the calculator. We clear out all this other nonsense. Okay, and we type in the equation that we're looking at: 4x cubed minus 3x squared. 4x cubed minus 3x squared. 4x cubed minus 3x squared. Let's see, large. Okay, so I put that in there. I graph it. I go to zoom 6. I graph again. Yeah, it's sort of good. Okay. Probably could zoom, make the window a little bit less wide, and let's make it negative, I don't know, negative 3 to 3. Let's see what that does for me. I'm vamping. Oh, that's a little better. Okay, so my window, my interval that I was looking at here, is from negative 1 to 2. So you probably remember this from pre-calc, that you can use the calculator to do some of these integrals. Well, you still can, but we're going to, now that we actually know what we're doing, we're not just pushing buttons, we're going to go with it. So down here at number 7, there's a little thing that looks like the integration sign. Why, you may ask, does it look like the integration sign? Well, because it is. So, yeah. You done? All right. So I hit enter, brings me back to my graph. My lower limit is negative 1. My upper limit is positive 2. And I know you won't be surprised because you've seen this before. Behold, it shades it in. So the integral, the area under the curve, or and so this is really integral because it's positive area up here, negative down there, so we just come up with a number. So the integral is 6. And so what I can do, let's see, what was the interval? The interval was 3, right? So 3 wide. Well, we don't need the calculator to do this, do we? So the integral is 6, so we've got 1 over 3 times 6, and I believe that's 2. Okay? Here's the thing with the AP exam. If you show the setup like this, you can go right from setup to answer, and it'll be fine. So, on certain quizzes, tests, I will allow you to do the setup and the answer. There's somewhere I still want you to do it the old-fashioned way to make sure that you do know how to do a definite integral by hand. But if the calculator does the work and you know how to do the setup and you show the setup, we'll be all good. Okay? So Now, if we wanted to do it from here, by the way, I can just now take this, that answer, divided by, so it brings me back to my home screen, divided by 3, and there's the answer. So, you don't necessarily have to type all those numbers, because if it came out to be some other number besides 6, it'll just pull that number right back to the home screen, and you'll go. Okay? I think that's about all. Let me just make sure that I haven't skipped anything. I don't know. There's that. Oh, that's the homework. Another little picture of Goldilocks and the 3 bears. Delightful. Okay, so we for the average value, we do the integral over the interval. Okay, for the mean value theorem for integrals, we're looking for the just right rectangle. Integral over interval. If I can spell right or color, I don't know which. Okay, that's how we do the average value, the integral over the interval. We've learned about setup. We've learned about the mean value for theorem for integrals, the just right rectangle. Oh, things we've done today. So, thanks for watching, and see you soon. If you have questions, of course, you could ask. Bye-bye.